in order to convert this to rectangular coordinates, we need to start by solving for cosine theta. So if we divide by 3, we get that. And for the y, if we divide by 4, then we get those equations. And now we recall our trig identities, which say that sine squared x, or theta, plus cosine squared x equals 1. Now we're going to do a substitution. So here we have cosine theta, and here we have sine theta. So let's just substitute in those two values. So we get y over 4 squared plus x over 3 all squared equals 1. And we can continue with that and say, well, that's y squared over 4 squared plus x squared over 3 squared equals 1. And you're expected to know that this is an ellipse centered right here, and the number associated in the x direction is this 3. So you go 1, 2, 3, 1, 2, 3. The number associated in the y direction is here, 1, 2, 3, 4, 3, 4. And then we have an ellipse that goes through those points. Convert this rectangular coordinate to polar coordinates. So in rectangular you have x and y, and in polar coordinates you have r and theta. So let's start with a picture of what this looks like. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So in rectangular coordinates we have something like this, where this is 3 and this is r6. Of course it's negative 6. Well, to find the radius we're just going to use Pythagorean theorem. So that's going to be the square root of 3 squared plus 6 squared, which is 9 plus 36. So it's the square root of 45. And in this case, that simplifies, doesn't it? That's the same as square root of 9 times square root of 5, which is the same as 3 root 5. So that's our radius. So we've answered that already, so that's 3 root 5. Now we just need our theta, which we're going to get using inverse tangent. So for this angle right here, we're going to do tangent inverse of y over x. And the y is negative 6, and the x is 3. And when we put that in our calculator, we're going to get the following. So I'm getting negative 63.4 degrees. Now what they're probably going to ask for in the test is an answer that's between 0 and 2 pi, or between 0 and 180, or 360 should I say. In which case we can get a positive version of this simply by adding 360 degrees. So if we add 360 to that answer, we're going to get 296.6 degrees. Alright, if you plug in negative 9 here, you're going to get 0 over 0, which doesn't really tell us anything, so I hope no one's going to put 0 as their answer. What we need to do here is factor, and when we factor, we're going to get, let's have a look, x, and we're going to get a 9, and a 4, and that's negative, and that's positive. And when we cancel those, we're actually left with 1 over x minus 4, which when we plug in the limit as x goes to negative 9, then that's going to give us 1 over negative 9 minus 4, which is negative 1 over 13. Okay, to answer this question we need to consider the left-sided limits and the right-sided limits. So let's start by considering the limit as x goes to 2 from the left side. So which one of these two functions do we consider? Well, this one is from the left, since it's x less than 2. So let's just plug in 2 into here and see what we get. When we plug in 2 there, we get 3 plus 2 squared, so that's 3 plus 4, and that equals 7. So now let's do the limit as x goes to 2 from the right side by plugging it in here. Well, if we plug it in here, we get 2 plus 6, which is 8. Since these two numbers are different, the limit does not exist. Use the limit process to find the slope of the graph at this given point. So just like we did in class, you're going to have to find the derivative, so you're going to have to do the whole f of x, oops, I did that wrong already, f of x plus h minus f of x all over h, and that's the limit as h goes to 0. So if we plug that into our graph here, we're going to get the square root of x plus 3 plus h minus the square root of x plus 3 all over h, and we're going to have to take that limit. And in order to deal with this, because obviously when you let h equal 0, this is going to give you an answer of 0 over 0. So what I showed you in class was to multiply by the conjugate. So we're going to do x plus 3 plus h plus x plus 3 over the same thing. So x plus 3 plus h plus x plus 3. And I'm going to let you finish that on your own. You should be able to see that this is an a minus b and this is an a plus b, which gives you an a squared minus b squared. And as I say, I'll let you finish that on your own. I probably should also add that once you have your derivative formula, you then take this point right here, this x, and you plug it into your derivative, and that will tell you your slope at the given point. In order to answer this question, we need to just consider the most dominant terms. So on the top we have this, on the bottom we have this, and if we put x squared over 2x squared, the x squareds cancel, and we end up with just 1/2. So that's your limit. In order to achieve this question, we need to start off by finding the unit vector. And the way we found the unit vector was to find the length of this vector right here, and then just divide that vector by that length. So let's just do that. Let's just come over here and say, okay, 3, 2, 1, 2, 3, 1, 2. There's my vector right here. It goes along 3, and it goes down 2 units. So the length of that vector is the Pythagorean theorem here. So it's just square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, 13. So a unit vector would be given by, would be given by 3 over root 13, negative 2 over root 13. And that's the unit vector. Unit means its length 1, but we want a length of 5. So we achieve that simply by multiplying this whole thing by 5. So the final answer would be 15 over root 13 and negative 10 over root 13. That would give us a length of 5. So find the component form of the vector v if the magnitude of v equals 6 and the angle it makes with the x-axis is 120 degrees. So I think a picture is going to be very useful here. So 120 degrees looks something like this. So there's my 120. And if that's 120, that means that this angle here is going to be 60. And I also told you the length of this vector. So the length is right here, that's 6. So this is 6. And now we have a special right triangle, don't we? So how do we deal with a special right triangle here? Well, from the long side to the small leg is half, so this is going to be 3. And then to go from this side to the final side is going to be 3 root 3. And so now we have everything we need to find our vector. So the x direction is negative 3, that's this right here, and the y direction is going to be positive 3 root 3. So how could we use back substitution to solve this problem? Well, we already know They've made it very simple for you. We already know that z equals 2. So now we look at this equation and we say, well, y plus 3 times 2, because we just said that z equals 2, equals 5. So y plus 6 equals 5. So minus 6 minus 6, and we know that y equals negative 1. Now that we've done that, we go to the first equation, and we say that x minus 2 times y, which we now know is negative 1, plus 3z, which is 2, equals 9. So that's x plus 2 plus 6 equals 9. So x plus 8 equals 9. So x equals 1. So our final answer would be 1, negative 1, 2. You need to be able to row reduce this matrix. So let's see what we can do here. First thing, I'm going to flip these two rows into different positions. So the 1, 2, 4 is now going to go on top. 2, 3, 1 there. 2, 4, 8 on the bottom. Next, what can I do? Well, I am going to do this one times negative 2 plus the one below it. So I'm going to leave the 1, 2, 4 on top, and I'm going to multiply by negative 2 plus this row. In other words, negative 2 times row 1 plus row 2. That's what I'm doing. So that's going to give us a 0, and then negative 2 times 2 is negative 4 plus the 3 is negative 1, and then negative 8 plus 1 is negative 7. And then for this one right here, I'm going to do the same, except I'm going to do negative 2 times row 1 plus row 3. And you're going to see very quickly that that gives us 0, 0, 0, which means we're not going to be able to completely row reduce this one. So we can times row 2 times by negative 1. In other words, that's going to give us a plus and a plus here. And then the only last thing we could do is we could do this row times negative 2 and add it to row 1. So row 2 times negative 2 plus row 1. So that's going to give us 1, 0, negative 14, negative 10, and then we're going to have 0, 1, 7, 0, 0, 0. So that's as good as it gets. Can you find the determinant of a 2 by 2 matrix? Well, let's just explore the rules here. We do that times that, which is 3 times negative 1, minus that times that, which is 2 times 4. So that's negative 3 minus 8, which is negative 11. Oh, and a warning on the test, this is going to be all sorts of fractions, so make sure you know how to deal with the fractions. Could you use the law of sines to solve this triangle? Well, the law of sines says that, well, let's just do it this way around actually. It says that a over sine of a equals b over sine b equals c over sine c. And recall that capital letters refer to angles and small letters refer to sines. So let's just plug in what we've got. We've got, how about, that can be our a, so x over the angle opposite, which is this one, so sine of 71, equals 12 over the angle opposite that, which is 46. So to solve that, it's going to be really simple. It's just x equals 12 times the sine of 71 over sine 46. Make sure you're in the right mode on your calculator.